Hi there, I'm Brendan Burns, CVP for Azure Resource Manager and DevOps in Azure. Have you been wondering the best way to describe and deploy resources to the Azure cloud? Well, the modern cloud-native way to do development and deployment of Azure resources is Infrastructure as Code, or IAC. With Infrastructure as Code, you use a simple text format to describe your resources, and then you can take that description and use it to reliably and repeatedly deploy your application around the world. Now, traditionally, infrastructure as code languages have been a little complicated, hard to learn, and honestly, not that much fun. With Bicep, a new infrastructure as code language from Azure, we've put a real focus on designing a language that's easy to start with, fun to use, and has great tooling in familiar environments like VS Code. Whether you're a beginner in the world of infrastructure as code or you have a bunch of experience in ARM templates, we invite you to join us on Microsoft Learn Live. There, we're going to have a series of lessons with subject matter experts on the Bicep team, helping you understand the best way to use Bicep to do infrastructure as code on Azure. Along the way, you'll learn Bicep basics, get to know the tooling in VS Code, and even learn a lot about Azure resources along the way. We're inviting you to come and enjoy this free learning experience in a series of weekly lessons starting Tuesday, March 8th, 2022. We hope to see you there.
And welcome to Microsoft Learn Live with Manage Changes to Your Bicep Code using Git. I'm Steve Murawski. I am one of our principal cloud advocates here at Microsoft. I'm on the cloud native team, and I've been in the infrastructure as code space for quite some time. And joining me today is one of my good friends, Brandon Martinez. Brandon, why don't you introduce yourself?
Sure. Thanks, Stephen. So I'm Brandon Martinez. I am a senior customer engineer working in Fast Track for Azure, specifically ISVs and startups. And I too have been in the infrastructure as code and DevOps space for quite some time now, probably a good decade or more. Awesome.
Wonderful. All right. So let's jump into our slide deck here. Perfect. Wonderful. Now, there is a Learn module that we're going to be following along called Manage Changes to Your Bicep Code using Git. You can follow along at the AKAMS link, Learn Live, and it's 2022-04-19A, and that will take you right to it, or you can use the QR code. Now, as part of this, you have an opportunity in the chat to ask us questions as we go. As we dive into the topic, we'll kind of outline what we're gonna go over. And in the chat, we have help sitting there waiting to help us answer questions. They're going to funnel questions to us, possibly to answer live as we're going through the content. So why don't we say hi to our moderator? Brandon, you know our moderator.
Yes, we are joined today by one of my colleagues. He's actually on my team, Josh Waddell. Thank you, Josh, for being here. And he will be moderating and fielding those questions to us. So thank you, Josh.
Good deal. We appreciate all the background help that is getting this Learn Live brought to you today. So let's get into it. Now, you mentioned there's a Learn module. Again, the QR code can take you there. What I would recommend is that after this event, or after you watch the playback, then you go through and actually go and do all the hands-on work in that module. Everything we cover today, or almost everything we cover today, other than Brandon and I's personal experiences, will be available in that Learn module and give you some practical hands-on experience.
Yeah, and of course, this is being recorded, so if you do want to hear that hands-on experience that we have, you can always rewatch this later.
All right, Brandon, why don't you take us through our learning objectives for today?
Sure thing. So as we already mentioned, the module is managing changes to your Bicep code using Git. So we're going to hit a few topics today. We're going to explain the benefits of version control and Git. We're going to commit a Bicep template into a Git repository, and we'll view the history of your changes. So actually going through and using Git with Bicep. We're going to create and merge a branch, and we'll talk about why that's also important to do. And publish a Git repository to GitHub or Azure Repos. We'll actually be doing GitHub today so that you can collaborate with colleagues, teammates, friends for personal projects, and really anything that you want to do and collaborate with the world.
Awesome. Now, so when we start out this process, right, it really helps. And what a lot of the way a lot of these modules are set up is so that we have kind of an example scenario. So we're going to use our infrastructure as code skills that we've been building up over the past few weeks with Bicep. And as our experiences kind of grow and mature, we really need a way to get a handle on how we track those changes, how that evolves, how we track that over time. And we're going to use an example scenario to kind of highlight what that might look like if we were, for example, responsible for deploying and configuring Azure infrastructure for a toy company. Now, if we're in that role, we've got a bunch of Bicep templates that we've created already, right? We've learned a bunch of skills in this Learn Live series coming up to this point. And so now we've got a bunch of Bicep templates. They're all stored locally on my computer, which is great until my computer crashes, right? And it doesn't help Brandon any if they're all on my computer. So we want to put them somewhere to help keep track of them. So we get some organization around it. We want to make sure that when we're deploying stuff into our production environments or even into our test environments, right, that the templates are effective working templates. And we want to make sure that we can enable experimentation. So how do I add that new feature, or what will happen to my environment if I enable this flag in an Azure service, right? So what we really want to do is take advantage of tools like Git to help us reach those goals. Now, Brandon, you've been working in the software development and infrastructure as code space and DevOps space for a long time. When you think about adding source control into the process, right? How crucial do you find that?
That's a great question. And as someone that's worked with many different teams of different sizes and skill sets, honestly, one of the first things that I make sure that my team has when we're developing software is a good foundation in version control. And Stephen, for a lot of the reasons you already mentioned, whether it's to enable the collaboration or to not necessarily use as a backup, but it is good having a copy of it somewhere, as well as the experimentation piece. Like, I can think of several times where I went to develop some software and I just didn't actually know what I was going to be doing. And it gives me a great opportunity and my team to be able to try things out, prototype, proof of concept, without worrying about destroying the main production branch. And that goes not just for software, but for infrastructure, like in Bicep.
Yeah. So, when you talk about team development and stuff, I also don't want to lose sight of maybe we've got a sole admin or a developer who's out there working in a small or medium-sized organization, or even a larger organization, but a very siloed or separated unit.
Yep.
Because that was me. When I first got into the tech space, I worked for a municipal government. I was working for one particular agency of that municipal government, and I was the sole IT person for that. And I was writing a lot of scripts. And so my journey into source control started with Subversion years and years ago, right? And just even though it was just me, I wanted my scripts and things in source control so that I had that change tracking, so that I had that way to experiment. I had that way to make sure that when I was actually using stuff, that it was going to work. So for me, these scenarios really resonate and track to what I've been doing in my career for at least the past, 15 years.
I want to add a point to that, actually. So there's this concept of building a proof or a prototype, like a proof of concept. And, over the past decade or so, I've learned that there's really no such thing as a proof of concept, because no one wants to pay for something twice. No one wants to spend the time twice. So you had asked, like, in my experience, like, where does version control fit in? And honestly, for any project, whether I'm siloed and it's my own project, it's a team project, or otherwise, I always start off with a version controlled solution. because I never know when that's going to end up on someone else's desk, even if it's my own.
Yep. Yeah, I actually wrote a blog post years ago, called "It's Just Temporary," because with that in mind, right? Like it's never just temporary. All right, let's
The
get into
temporary thing will
really
end up in production.
yeah, let's get into and really start talking about what Git is, why it's important, and how it works with our Bicep code, because that's what people are here for. Brandon, why don't you kind of take us into what version control is?
So version control, so we've already used the term a couple of times. Version control really is a practice to maintain, watch the history of files that you are working on your local machine, and as we already mentioned, that you would eventually share somewhere else. So it allows you to track changes that you make to files. You can view that history of changes that you make. You can also work with multiple versions. So we already talked about like creating a experimentation, and we'll talk about branches later, but an experimentation like branch or version of your software, and version control helps enable that. It also lets you collaborate, as we've talked about, if you're in a team, whether that's just one or two people, you yourself, and another person, or a much larger team. If you have tens, if not hundreds of people that you're collaborating with, like in an open source project, or if you're in an enterprise or an ISV type scenario and you're working on a product. Version control helps you have good practices in managing your files and managing that history.
Yeah, and one thing that we didn't mention here, but it's kind of alluded to in the collaborate section, is version control is ultimately a communication tool, right? It's a communication tool. It helps us share what the current state of things are, and in our maybe our main or trunk branch, right? That's might be what's currently in production or what's next to go into production. And then we have our experimentation that's happening in some other branches. And even if you're a sole admin or a sole developer or a sole whatever, right, working on, and using source control or version control, it's communication with your future self, right? Like, what is the history? How did this change? Because I'll tell you what, after I work on something and I put it aside and I come back to it 6 weeks later, I don't remember exactly how that thing changed. I might have some ideas, but depending on how much stuff happened in between there, right, it can be kind of tricky. Now, we've gone back and forth on some terms here a little bit, and you might hear source code management, source control, version control. For the purposes of this discussion, you can get pedantic, and there's a lot of different, you can kind of narrow down some specific definitions of things and find, if you want to argue about it, that's great, right? That's not what we're going to do here. For the purposes of today's discussion, if we say version control, source code management, source control, we're talking about the same thing. We're talking about tools that are designed to really manage all types of files, but they're optimized for that text file management.
Yep.
So now we've talked about a little bit about what version control is. Why don't we dive into what Git is? Brandon?
Yeah, so Git is one of the many different version control technologies you can use. There's actually many others. So Stephen actually mentioned one earlier called Subversion, Git, Mercurial. If you're an old school Microsoft developer, you may have heard of like Visual Source Safe. There's many different technologies out there to version control and manage your code.
Team Foundation version control.
Team Foundation, yeah, TFVC. All the wonderful initialisms and acronyms that we love to use. Yeah. So Git is today by far the most popular version control technology out there. It's grown into a huge, huge tool utilized from everything from open source projects to large enterprise projects, and it's a great way to manage your software. So Git at its essence is actually just a CLI or command line tool. And most of the samples that we'll be using through the rest of today, you'll find documentation and other examples online, but you'll see that we will use the CLI today. You're not restricted to just the CLI. You can use tools such as Visual Studio Code, which we'll be using later today as well, that helps if you don't want to memorize a bunch of CLI commands. But ultimately, under the hood of any UI-based tooling or anything like that, Git is just a command line tool with different actions or operations that you can do to version control your software.
And I will highly recommend, even if you find a UI that you like if you like the way Visual Studio Code works with Git, or you like, Git Kraken or some other tool that's out there that that will help provide a visual of what you're doing. It is really, really important to understand the Git command line, and because when you're troubleshooting a problem, and problems will come up, right? You're gonna hit a complicated scenario at some point, and it's just the nature of life, right? And a lot of the help that you're gonna find when you're searching for your problem, because none of us know all of the Git things, and so I'll go search and I'll find stuff on Stack Overflow, or I'll find some blog post somewhere, or it may be just in the docs. Understanding what CLI commands match to what your UI is doing can be really, really important. We'll talk about one example specifically today around Git fetch and Git pull, but we'll put those off to the side for just a moment. Before we even get to that, we really need to kind of land what is a Git repository. And a Git repository it's a collection of files and directories, and this is not going to be the definition that you find out in the Git documentation. There's going to be a lot more specificity and things there. But ultimately, it's a collection of files and directories whose state is tracked by Git, right? And that seems like super simplistic or anything. But Git it's a distributed version control system, which means that I can have multiple copies of this repository in multiple places. None is really the overall leader by anything tracked in Git. It is something that we would decide as a convention, and we'll talk about that as well. But really, it's this idea that starting in some folder or some file, or I'm starting some directory or folder, we're going to say this and everything under it is going to be tracked by Git. How do we do that? We do that with a command git init. And git init run from the command line in the directory that we want to be the root of our tracked repository, sets it up to be tracked, sets up to track changes in that repository, right? So it's a really, really simple, really basic command. But and we're going to actually go through and create a repo in just a little bit. Now, Brandon, how does Git really work with folders?
Yeah, that's a great question. And sometimes, especially I talked about like working with teams and making sure everyone has a base understanding of Git. Sometimes when you start working with Git, it seems a little, for lack of a better term, magical in how it creates a repository. So as you were just saying, a repository is just a directory that we're going to track files in. And what ends up happening is behind the scenes, Git makes a special directory, and that is how it's tracking it, is essentially a bunch of metadata hidden mostly from you, but it uses that to then track the changes that you make within that folder or directory. So you can add files, you can add subdirectories, and as you add them, which we'll learn here shortly, you can stage and then commit those changes to Git, and then that's tracked kind of hidden away from you. So, you run that git init command, and it might seem like, okay, nothing changed. I don't see anything different. It's just a folder, right? And when we go through the exercise, we'll at least show the folder, but know that you have basically blessed that directory with a hidden Git metadata folder that will then track those changes for you. And that's where all the Git CLI commands come in. You are essentially saying, look at the things I've done, and then track those in that hidden Git metadata directory.
Sounds good. So how does all this help us with Bicep, right? Now our Bicep code it's just text files, right? We've given it a .bicep extension. So which helps, some of our tooling in Visual Studio Code make magical things happen, and helps us complete resource types and all that kind of fun stuff. But ultimately, it's a text file, right? There is, there's Unicode. It's a Unicode representation of what we want our Bicep code to be saved on disk. Now, that is a perfect fit for working with a tool like Git. So Git, we've got metadata saying, hey, we want to track stuff in this folder. Well, what do we want to track? We want to track changes to basically text files. You can track binary files and other file types, but it's most effective with text files. And this can help us undo and redo changes. It can help us see the history of changes to that file. We can edit files. Once we get into branching, we can edit files without impacting the work of others. And then we can contribute and collaborate with our teammates without necessarily stepping on each other's work. So let's dive into and talk a little bit more specifically about each of these things. When it comes to history, Brandon, what do we see?
Great question. So as already mentioned, if you're tracking your Bicep in a Git repository, it's text-based, you're making adjustments. So if you've been following along with this Learn Live series, you've learned how to create everything from your basic Bicep files to modules. You've done everything from conditions and loops to referencing existing resources. So when you're building out your Bicep, your infrastructure as code, you're probably making a lot of changes. Most infrastructure, even in the most basic sense, is really kind of complicated. For, let's just say, a basic web application, you could be creating an Azure app service with a storage account and a database. That's 3 separate resources that have to be configured. And as you're making those changes, you might want to track what environment variables you set in your app service, how you configured storage account for the different tiers of storage. For the SQL database, how did you set up the admin? How did you set up the actual database and the server and firewall rules? So as you're making these changes, it's good to keep track of all of those different steps. I probably can't even count the number of times that I've made changes to my infrastructure, and I didn't remember what the old values used to be. So being able to just kind of take a step back through time and look at those and go, oh, right, I accidentally removed this environment variable that makes my app so that it can run.
Once we have history, Brandon, the next kind of concept that we've teased a time or two is branching, right? So we're tracking history. What is this branching concept that we've kind of teased to folks?
Yeah, great. Using the same example I was just using, when you're defining out this architecture. So, you build that app service, the SQL database, or things like that. Let's say you want to introduce a new service, right? You want to introduce Service Bus, or you want to introduce Azure Managed Cache for Redis or something like that. But you want to kind of prototype it a little bit. You want to experiment and see, what does that actually look like in my solution? Branching lets you basically save your spot in the old branch, so main, trunk, etc., and step aside and essentially create a quote unquote copy, but it's not a copy. It's still in the same working directory, but it feels like a copy that you can then go and experiment. You can create that history still. So we'll talk a bit about committing code and things like that. And it lets you experiment and create changes somewhere that does not disrupt other people working in that same repository. And we'll talk more about branching and merging later as well.
And I think, those two things, having that history tracking, having the ability to kind of work off to the side in a branch, kind of leads to, those are kind of foundational to bringing in this idea of collaboration. And how does Git kind of enable collaboration for us?
I really like that you used the term earlier that ultimately version control and thus Git really is a communication tool. So when we're looking at our code and we're building solutions and we're making those changes, yes, we have the tangible, right? The infrastructure or the app or whatever we're building, but ultimately it's how we can also communicate with our teammates, the open source community, whoever you're working with, to say, these are the steps that I took to get to where I'm at today. And this is how it compares to your branch or the main branch, or if you're doing things like Git flow, like the branch for an environment or something like that. In trunk-based development, which we'll also talk more about later and define that a little bit better, in my team, that main line is what goes to production. So here are my changes that I'm giving to you to review or to sync back into that main line. And it lets you just work with your team in a much better way. And then we also mentioned on this slide that if there's a conflict. So let's say Steven has a branch and I have a branch, and we both decide to change the same file at approximately the same line. Maybe he adds an environment variable and I add an environment variable. And we go to commit those and we merge those two branches together. Git might not be able to figure out who gets priority there, and we may have a conflict. Thankfully, Git has a process for managing that as well, and we can resolve that conflict by choosing one or the other. Maybe we do a manual merge where we can say, actually, both of these changes are important. Let's just make a fix in place and then commit that. So it lets us work together, even on the same files, and to be able to manage and merge those together successfully.
Yep. Now merge conflicts are out of scope for this particular Learn module. We do have another learning path on Git in Microsoft Learn. It's a more general learning path, and it goes into branching, merging, and dealing with conflicts. So if you wanted to get your hands on with that, we definitely have content in Microsoft Learn to help there. Now, as you're talking, right, we've got a really strong focus around working with my team, working with the other folks doing infrastructure as code. One thing we haven't mentioned is this is also a communication and collaboration tool with, for example, our security or auditing folks, right? Because now we have a real change tracked history of how our environment has evolved over time.
Yes.
Who made what changes, what the setting, what the defined settings are, and we can go then and that can augment any of our our auditing or compliance processes that we may have to meet. We may have security review that wants to be able to go through and check settings to make sure we're pulling from Key Vault where we need to, or that we don't have clear text things that we shouldn't have. And so it's not just collaboration within a specific team. This can be collaboration across teams as well. So putting our code into Git or some other source control repository can definitely be a big win there. Now, let's talk a little bit about repository structure. What should my repository look like? Now, this is an example, a suggested structure. There's actually another Learn Live coming up. I believe it's actually the next one. We'll find out at the end. But there is a Learn Live that we'll actually talk much more specifically about the project structure for Bicep projects. But we might have, and there's a lot of words here. Let's actually jump ahead one slide and see a visual. So we might have a project that looks something like this, where we have our toy website project. That's a source of our repository. So inside that folder is where I would have run git init. We have a README file, which tells me about the project. We have a deploy folder, which is going to have our Bicep files. In there, we'll have our main Bicep. We have some modules. We at the same level as the deploy folder, I have a docs folder, which might go in and explain my architecture. And then I can have a source folder, which will have the content for the site. This is one way, for example, that we could structure a repository that would work with Git, that would allow me to track independently all of the various things I care about. Now, Brandon, I'm sure you've seen a number of different repository structures, and especially depending on the type of language the project is in. If it's a software project, that may have some similarities, may have some differences. What do you think?
Yes. So in this specific one, consider this descriptive opposed to prescriptive. So most of the time when you hear about, the folder structure, regardless of, the language or frameworks that you're using, most of the time those are going to be suggestions. So, I have a background in C# and Node and some other open source languages, and their description of what a folder structure could look like, there's similarities, right? Having a source folder, maybe a docs folder, but maybe where they put them, or how they structure them, or even just the name. So you might see a source folder, you might see a lib folder, for libraries and things like that. These are just suggestions to help you essentially build a better structure so that you can work in a space in a consistent way. I generally tell my teams and any partners or customers I work with, the most important thing when defining structure is that you and the people you're working with agree on it, and that you have something that you can do consistently.
Yes, consistency, right? That becomes the thing, right? Especially when you have to collaborate across multiple teams or multiple organizations, especially like in the open source space, and that's where like a lot of the language dependent stuff seems to come in. All right, so let's get into actually making changes inside of a repository. Now, the first step that we have to do is stage our changes. Now, Brandon, what's all involved in that?
So this might seem like a weird concept if you've never worked with any version control before. The idea of staging something, like what does that mean? Like, my file's there. Why do I have to do a step? Like, this is strange to me.
Yeah, we
And
told
what
it get it. We told it to track changes. I said get init, didn't I?
exactly, right? And that's, at first glance, that might be what you think, but what staging is doing is you are saying that I want this snapshot of a file to be ready to commit, to make that final step, to be part of the history that we've been talking about. This is that version of the file I want. So when you create a new file or you make changes to an existing file, you need to stage those changes. And you can do that with this command on the screen, the git add. So git add and then the path to the file. Now, keep in mind, that's a relative path. So if you're already saying that deploy modules folder, you can just say git add Cosmos DB Bicep. But doing git add stages the changes at that point in time. And it's really important to note as we do that, that this is the first step in committing. And I'll make one more note as well, because we've already talked about UI tools. There are certain UI tools, such as VS Code, that give you the option to auto stage. So if you want to basically bypass the manual add, some tooling will go past that. But as Stephen mentioned earlier, it's important to still know what's going on under the hood. You want to know that it is doing an add and then a commit.
Now there is one specific call out I want to make here, right? When you stage a file, Brandon just said that there's a two-step process here, right? So once we stage a file, there's another step that we have to take. And if we make more changes to our file before we go to that next step of committing it, Git won't record those changes. It takes a snapshot at that point in time of when we say git add, or that we will that it's going to work with, right? So if you make further changes before you get to your commit, you have to go add it again. So it's something that even still today catches me up every now and again. And so, learn from my pain.
And mine happens to be too.
So, all right, how do we then? What's that second step look like, Brandon?
Right. So the part two of the two-part process to take that file and truly get it part of the history is to commit those staged changes. So if staging is preparing the file to be put into the history, the commit is actually creating that historical record and saying, this is the snapshot I want as part of my history. And we do that with the git commit command. So here we see on the screen git commit, and then we do -- message, and we can associate a message with this commit. Now, going back to the point made earlier of this being a communication tool, we are communicating, whether to a team or if it's just your own repository, to your future self, why you made that change. And I would recommend that your changes are relatively concise. You don't have to write a book, but just say what you did. And, this can contain more than one file. So that should be noted that, it might be just a single file. Like I added Cosmos DB, the Cosmos DB bicep file to my repository, as we see here. It could be multiple files. So maybe Cosmos also required you to create some networking rules or something like that. Just say added Cosmos DB in networking definitions, and it can be more than one file.
Very good. All right. So once we got now, one thing I want to call out there too is it's one or more files that we've staged. You can't call git commit unless you have staged files. So it won't error. It just won't do anything.
Right.
I may or may not have done this several times today already. Right. It's an easy one to miss. Right. Like forgetting to restage, but also committing before you've got staged stage files. Did I stage those? And yeah. So if you git commit without any stage files, nothing will actually change in the repository. All right. Now, once we've got commits in our repository, we can start seeing some history. And so we can see what those changes are. And so Brandon mentioned that we had a message, right, that we added with our commit. And if we run that command that was just up on the screen a moment ago, and we'll be up again here shortly, there we go, where it says git log, and I'm giving it an parameter of pretty and saying one line. That means I want one line of output that will have the commit hash and the message, at least one line of the message, so I can get a quick view of kind of the history of that repository. Those commit messages come back in that history. More information, but the pretty one line, especially if I'm doing a large selection of commits. In this case, I'm looking at the whole history from this repository. That pretty one line is a really handy one to know. Now, the next thing we have is how to look at an individual file. So I can look at the history of my full repo, or I can get what are the changes that impacted this particular file. And so any commit that changed that file can show up here. And this would show, because I'm not giving it the pretty one line, I would get the full commit message, which is usually a multi-line thing, because it's going to have a hash, it's going to have a timestamp, it's going to have who did it, and it's going to have any of the commit message that's there. And we'll get a chance to go hands-on with both of those commands in just a moment, as we switch over to our friend Brandon to walk us through initializing a Git repository, staging and committing files, and then going and viewing some history.
Awesome. Thanks, Stephen. So you'll see I have VS Code open here. As a note, like we said, Bicep and really any other source code, text files, you can use any editor you want. So if you want to live completely in a terminal, you can use VI, you can use Nano. I like VS Code. It's my favorite source control or source editor to use. So that's what we're going to use today. One thing I really like about it is that it has an integrated terminal. So instead of having to run multiple applications, I can actually open a terminal here. So if I was in VS Code, I could go to terminal and I could say new terminal. And I can see that it opens a terminal here that I can start doing things with. Now, for the sake of today's presentation, so that you can see better, I'm actually going to open a full screen terminal since we'll be working in there quite a bit. So first thing we have to do is make sure we even have Git installed. So I'm just going to check to make sure it's there. So I'm going to call Git version, and I can see that I already have Git, and this is the version that I'm running. If you don't have Git, so if that said, Git not found or something like that, go ahead and just search for Git and install the appropriate version for your operating system. I'm on a Mac, so it's already built in. Go ahead.
As I said, the Learn module actually has a link to the page, so the Git projects installer page, so you can find the appropriate distribution and installer for your platform.
Excellent. Yes, definitely. Use the learn module to follow along. So actually, as a note, all of the commands that we'll be running, for the most part, will be in that module as well. So if you missed something, or you didn't catch the description, or if you feel like we're moving just a little too fast or something like that, all of this is in the exercise in that learn module. So thank you, Stephen, for the reminder.
No problem.
Cool. So now we know we have Git installed. We checked the version. It's there. We're ready to start using it. As a note, if you do install it and you get an error, you might have to just reopen VS Code. Quick note there. So first thing we're going to do is we're going to configure just a couple things in Git so that we can be good communicators. And to do that, we're going to do git config. We're going to do global username. And here you can put your first name, last name. If you are thinking about contributing to an open source community and you have an alias or something like that, you could do that here as well. I'm just going to use my name. Okay. And we're going to do another similar command.
Now, one of the important things about putting these commands in is Git will use this data when you make a commit. So it will tack on the username and the username that you just set and the email that you're just about to add.
Yep. I'm going to put my email address and hit enter.
Send all your Git questions to Brandon Martinez at Microsoft.dev.
Feel free. I may or may not answer. No. So there's my email address. And then you might say, like, well, okay, how do I know that worked? Well, there's a command for that too. So we're going to do git config list. So what this does is it shows that I can see username and email right there, and that I have configured Git and am able to now contribute and communicate, and people will know who made those changes. So I'm just going to go ahead and clear. And now we're going to start moving into creating that repository we talked about. Now, I'm just on my desktop. I would highly recommend create a source folder or something where you can keep all of your source code, especially if you plan on being an active contributor. For the sake of ease, I'm just doing it on my desktop. So I'm going to make a directory for that toy website that we talked about. This is the example we've been using through the Learn module. And then I'm going to go ahead and move into that directory. Now I can see I'm in the toy website directory. Now, VS Code works really well when you're at the root directory of the project that you're working on. Now, I could stay here and I could still work with all the files, but it's nice to be able to just have it scoped to essentially my project. And I'm going to use this command. It requires proper spelling. So I'm going to restart Visual Studio Code and reuse my current window to get back to this folder.
No, that's a handy trick.
It is a handy trick. And I will be totally honest here. I did not know about that until completing this Learn module. So we can all learn from this. So, yeah. So I'm going to go ahead and just close the Explorer for now. And I'm going to open up that full screen terminal again. So we can see I'm scoped to the toy website. And I'm going to do git init. So here, by default, we can see that apparently I have an older version of Git because I believe they changed this in newer versions. So it automatically created a master branch for me. In newer versions, you'll see main. You can also specify the branch, as you can see here. Names chosen instead of master are main, trunk, and development. Apparently, I have not updated that config. So I now have a Git repository, though. Now, we mentioned earlier, and I'm going to show it now, and this is not in the module, I believe, but we talked earlier about how there's a hidden directory. We're not going to dive into it. That's well beyond the scope of this. But just for complete transparency, I'm going to take a look at hidden files. And I can see here that there is a Git folder that gets created, a .git folder, so that it's hidden. So we're not going to dive deep into that, but just know that there's no magic really going on here, that it's just all being tracked in that folder. So I'm going to clear my screen again. And now let's start building that structure that we talked about earlier. So I'm going to go ahead and make a directory. We're going to call it deploy. We're going to go ahead and open up our Explorer now. We can see there's my deploy folder. And we're going to go ahead and just make a new file. We're going to call this main.bicep, which if you've been following along with the Learn modules, is probably pretty familiar to you. I'm going to go ahead and hide this just for the sake of screen real estate. And I have my cheat codes on the side here. So I'm just going to actually copy this and paste it.
And all that is available in the Learn module as well as you're going through the exercise, so you don't have to come up with your own main.bicep. It's already there for you.
Yes. Yep. Definitely. Just like I didn't. I copied it from the Learn module.
Yeah.
Perfect. So now we have a bicep file. So this is just a very lightweight parameter-based file. Nothing amazing going on here at the moment, but just to create a file so we can see what tracking looks like.
So are you promising us that there is something amazing coming?
You know, we'll wait to see. Let's leave the suspense there.
Okay.
So we're going to go ahead and we're going to check the status of a repository. So again, remember that Git is nothing but a bunch of CLI commands. If you look at the UI I have right now, you can already see that source control in VS Code is saying you have a pending change here. Down below, I can see that my branch has been updated because there's an asterisk at the end. They're saying there's uncommitted or checked in changes available. Under the hood, though, the way that this UI from VS Code knows that that's true is it is checking the status of the repository. So I have no commits yet, but I do have untracked files. So that's what Git status does. And it lets us know that there are things that need to be either staged and committed, or you can also ignore files, but something needs to be done because now your file, or your folder structure rather, is not set up, or I'm sorry, is not at a state where everything is checked in. So your history is not up to date with what is on your file system.
Good deal. So I think we need to make a little change though, because don't we, right now the default branch is master, and we tend to prefer main these days. So how can we make that change?
Oh man, you're quizzing me. So let's
give you a hint. It's in the Learn module.
I know. All right. So we are going to go ahead and we're going to go ahead and change this. So right now we have master as the name of the repository. I'm going to go ahead and create.
There's a just do a dash capital M with git branch dash capital M.
Thank you.
Oh, you need main. Yeah. There you go.
There we go. Perfect. Thanks.
You bet.
It's the best of us.
Yeah.
And this is why, so I'll actually make a point of that because of my failings. So most of the time, I actually do use the UI tools because it's easier. I'm just being totally honest. So when you have to drop back down to the CLI, it's good to do every once and again, just to refresh your memory. So
yeah, I'm a CLI junkie. I am almost always in the CLI. I almost never use the UI for it. And so sometimes I find myself lost in the UI because the UI can call it can call operations different names. And so it can get a little wonky there, but you know what? I am happy I don't really care what tool you use as long as you're using source control. If you're using source control, I am a much happier person. So, all right, let's get back into this.
So,
and
we'll talk about this command more later, but oh, cool. It actually did force it off. Nice.
Yep. All right.
Back to where we were.
Yeah.
Sorry, we are good. All right, so we already covered Git status. So we'll do that again, just to get us back on track where we were. On branch main, no commits yet, etc. The tooling, we already went over that as well. So I'm going to go ahead and show in VS Code how you can see the tools and what they show. So I'm going to hit source control here, and I can see that there are active changes. So I can see main.bicep, and I can see that it has a U. U means that it is untracked. So those changes have not been staged or committed at this point. It is completely untracked.
Right. We've told Git that we want to watch this repository, but we have not staged anything yet. Remember, we talked about we've got that multi-part process, right?
Exactly.
All right.
So I'm going to make a note here because we've talked a lot about the Learn module. Right now, we're actually going to be doing 2 exercises. So if you are doing the module, this was the end of that first exercise. So now we're going to move into what would be exercise number 2 in the module.
Good deal.
So what we're going to do is we're going to do an add. So git add, again, is how to stage your changes. So we're going to do git add, deploy, and then main.bicep. So now we've just added that file. And actually, I'm going to use this just to show, again, how your tooling can help you out here. So we can see staged changes, right? So there's that staging that we were talking about before. The A means that it has been added. And if we do it,
now that's actually a really good point to call out here. Just can you go back to the visualization there? So stage changes, they can be add, they could be modify, and it can also be delete. So there are multiple operations that can happen that we're staging, even though we're using git add. Sometimes the changes that we make aren't just pure adding files.
Great point. Yes, there are multiple operations that can occur. And then I did a git status as well, and we can see that we have no commits yet, but there are changes to be committed, right? And that's that staging that we were talking about. So now that we have that, let's go ahead and actually commit this change. So git commit, we're going to give a message, and we'll say add first version. I'm really good at spelling. First version of Bicep template.
Your message itself is misspelled.
See, I'm terrible at spelling. It's more of I'm terrible at spelling whilst typing. So cool.
Yeah. So if you're doing a lot of this at the command line, -M is also a substitute for message. So you don't have to. And if you look in the docs for the Git commands, you'll find a lot of the shorter versions of these parameters. We're using the full parameters so you can more easily see what's happening.
Excellent. All right. So we've committed our changes. We can see our tooling just updated. So the one that was here and the asterisk and main went away. If we go back to source control, we can see that there's nothing here. We'll talk about this later, but we can see there's no more changes. We've committed. So we're good. So let's do something else. So let's go ahead and I'm going to do it right from here. I'm going to create a new folder. We're going to call this modules. Then inside of this folder, I'm going to create a new file. I'm going to call this app service.bicep. And this is where I'm going to cheat again. And I'm going to copy this text. And then let's go ahead and...
It's not cheating if the Learn module gives it to you to copy.
That's true. But I'm not typing it all, at least. So, so we have the app service bicep file here. And I'm going to go ahead and save this. So this is the amazing I was talking about earlier. I love app services. It's one of my favorite Azure services. So I'm excited. App service.bicep. And another great thing about having some good tooling, VS Code is showing me right here on my tab even that this is an untracked file. So it's just great visual indicators as you're working through a repository. So I'm going to go ahead and close that. And then we're going to open up main bicep. And then we're going to add in a reference to that module. So I don't remember exactly how many ago it was, but I think it was a couple modules ago, Learn modules ago. We learned about having modules in Bicep. So we're including this module in our main.bicep entry point. And again, just calling out, we can see, as Stephen mentioned, that there's more than one type of, I don't want to say, I guess change, we'll say change, that can occur. This is M for modified, right? We're not adding this file. We have modified this file. So I'm going to go ahead and close that. And then we're going to open up this source control pane. And I am going to click on main bicep. And I'm going to actually zoom out a little bit, so it's a little easier to read both of them. So in VS Code, we can see the differences that have occurred from the checked-in version, the committed version of my previous commit, so main.bicep, and compare that to what I just recently did. So notice it's highlighting the changes that have occurred here. So I can see that I've added in and modified this file to now include that module reference.
Yeah, good stuff.
And if I go and open up app service, we can see that I didn't have app services before. So it shows
so it's
nothing.
all new.
It's all new. Exactly. So it's untracked, all new. All right. So we are going to, instead of doing this at the command line, we're going to use the tooling now to commit these changes. So first thing we're going to do, Stephen, what's the first thing?
Is we are going to stage the changes. We're going to open up that little Explorer there, and then we've got a little. Nope, we can't commit yet. We got to stage them.
Nope. Tag, stash, remote, branch, pull, push, changes. There it is. Cool.
All right.
All right.
Oh, you're doing it the fancy way. See, I would just go through the individual files and pick what I wanted to do.
Oh, we could do that too.
Yeah, because there's a little plus, or you can. So you do all the fancy stuff.
I'm sorry.
That's okay. No, it's cool. Go for it.
I told Stephen earlier, I actually had to go and disable a bunch of extensions because this would not look the same. So yes, there are a couple ways. And this is what's great about tooling, right? It's super important to know the CLI, but with the tooling, it can make some operations a lot easier. So while yes, I could go and I could stage each of these, absolutely a valid path to go, I can also take advantage of the tooling and just say, hey, I want to stage all of these changes. So either one, totally acceptable. So we'll go through and we'll do it Stephen's way. So I'm going to stage this. So we can see it went from stage changes to changes, right? So behind the scenes, git add just happened. I'm going to go ahead and do this on the main bicep as well. Oops, sorry, on app services, backwards. So I'm going to go ahead and stage these changes. And now I can see that all the changes that I have in my repository right now have now been staged. I'm going to go up to the top here, and I'm going to say add app service module. I typed it correctly. So this is now the commit step. And if you recall back from when we were going through the slide deck, a commit can be more than one file. So I'm essentially saying that these changes, the stage changes, are related to each other in some fashion, right? Communication tool. I'm letting whoever, my future self or my teammates know that these are related changes. And I'm going to go ahead and commit that. So you could hit the checkbox up there. Again, I'm fancy. I hit Control Enter or Command Enter, and now those have been committed.
All right, so then we've got some history now, right? So how would I? Because we've got a couple of commits. So let's take a look at what it would look like from the command line if we use that git log command that we had in the slides. Git log -- pretty equals one line. Let's see what that looks like.
Say that one more time. I'm sorry.
Git space log.
Typing. There you go. Okay.
-- pretty equals one line. All right, so we get an individual line for each commit. It's got the commit hash. It's got the message. And there's also an indicator of what pointers we have. So main is at that. That's what the very top of our branch is main. And we've got the head indicator there as well. So that's our latest bit of development that we've committed. So, and I think we can see this in the UI as well, right? The UI calls it timeline.
Yes, it does. So we
Okay.
can go to the source control, or actually we can go to the file here, and I can choose main bicep, and I can open the timeline. So it's a panel below. Sometimes you can have these hidden. In this case, I already had it. And here I can see for that timeline the changes that have occurred. And what's great is I can actually click on these and I can see what happened at that specific revision.
Now that is useful.
It's very useful.
Yeah. All right. I think it's time that we get back into our slides because we've got a lot of other content to cover and not a lot of time to do that in. So we need to talk. We've now got our basic fundamentals of, hey, I have a Git repository. I can add files. We'll get in the history going. But now we need to start talking about branching and merging. So Brandon, run us through branching and merging. What's all involved here?
Yeah, we actually already touched on this actually a little bit earlier. We alluded to it. So branching and merging your changes in your repository is really an opportunity for you to take a step aside from whatever branch you're currently on. So, in the case of our example, we're on the main branch. Take a step aside and to be able to create a space where experimentation or new feature development can occur. And then ultimately, when we're done working on it, assuming that we're happy with those changes, we can then merge it back over to that main line. And merging is the act of taking the changes from one branch and bringing them into another branch.
Awesome. So once we have those branches, right? And we talked about that experimentation and having multiple active versions of a file. Brandon, I think you actually brought up that I'm in my same folder, but I could have multiple versions of the file, and branches are what enable that. And yeah, a branch lets you have multiple versions of your files, of the repository structure. There's a lot of different, you can make a lot of changes in a branch. But it gives us that way. So to create a branch, we have a couple of commands that we can use. And we're gonna, if you want to check out the other Learn Live series, we walk into like the multi-step process to creating a branch. Here we're going to give you the quick and dirty, the one that I use almost every day, and that's git checkout -b. So because git checkout is a command that lets us switch branches. If I use the -b command, that's to create a brand new branch. So git checkout -b and then the name of the branch. And that will create a new branch for me to go work in based on the branch I'm leaving. So if I was in main, whatever the state of main is at that time, that will be the starting state of my new branch. And then I can switch back to main with git checkout main and git checkout my experimental changes. I can go bounce back and forth and until I don't know where I actually am. But then again, that's where git status or the tools like Visual Studio Code, which is showing you which branch you're on, can really come in handy and help you. Because bouncing between branches can be fun, but it can also get you kind of mixed up as to where the state of things are.
Right. And I really want to emphasize the point that you made, that remember that most of these commands, actually all of the commands, are from the perspective of your current, what we would call working copy. The directory as the status that it's in now. So if you're in main and you branch, it is based on main. If you were in another branch and you branch again, it's based on that branch.
Yep. And when we're working on that branch, if we add, commit, change files, that's not going to change the branch we came from. That's changing the branch that Git thinks we're currently on.
Exactly.
Now, then once we've made the changes and we're happy with them, we need to bring them back. And Brandon, you introduced the concept of merging, and also you actually just set this whole thing up perfectly, because you brought the idea of we want to merge our changes back, but also setting the context of the branch you want to work from. So when we merge changes, we're merging from some branch into the branch we're working on. So if we're going to go and set this up, if we bring up the slide again, I would check out my main branch if I want to bring changes from my experimental changes into main. And then I would choose git merge and then the name of the branch I want to bring the changes from. And if I'm being a good citizen, I'm going to clean up my experimental changes once they're merged. And I can do git branch -d to delete the branch and clean up that, because I brought those changes into main, I don't need my experimental changes anymore. And that's actually one of the patterns that we see with trunk-based development. Now, Brandon, we got a little note here. What are we talking about here?
Yep. So this is, again, just really reiterating that point, because it is one of the more confusing pieces of working in Git if you're brand new to it, which is be sure that you are going to that destination branch for your checkout process. You are really just pulling those changes into your working directory when you do a merge. So just always double check that. I know, like, honestly, it still gets me once in a while. It's like, oh, right, I forgot to switch branches. So just remember that you are pulling into your working copy when you do a merge.
It's a critical point. Good. I'm glad we called that. I'm glad we called that out. So merge conflicts. We're not going to spend a bunch of time here, but we just want to call out. Brandon gave an example earlier today of how he and I might both edit a file in the same line, and Git doesn't know which one it should be, so we end up with a merge conflict. This can and will happen as you come across things. There are a lot of great documentation. There's a walkthrough of how to do this in another Learn module. So I would strongly suggest taking a look at that. Don't let your first merge conflict be in your production code, because it can be a little bit troublesome. Now, Brandon, we mentioned workflow patterns, and you talked about Git flow and other things. One I really like is trunk-based development. Do you have much experience with that?
Yeah, definitely. So in a trunk-based development, and this is actually a term that's been around like even pre-Git. Trunk was a term used back in old version control systems. And really, the whole idea of it is that if you were to think of a tree, and the trunk of the tree is where all of the branches come from, ultimately we're doing that same thing with our source code, and then we want to get those branches back to the main branch. Thank you. When we do that, we can merge in changes from experimental into that main line. And we know that main, because it is the trunk, the source of all other branches, is the most important. And generally, when we're talking software, is the production bound code. So it lets you create branches off that trunk, and then you can make those merges back into it.
Yep. And with the critical idea being we want those to be short so that there's less opportunity for those merge conflicts, right?
Exactly.
Cool. All right. Now, we've covered a bunch of the concepts that get us to working with a local version of a Git repository. And that's great on my machine. But how do we get Git working with multiple people? Right? How do we make this repository something that other people can access? Now, the first concept that we're going to come across here is publishing a repository, publishing changes. And you may remember from Brandon's demo how there was a publish changes button, right? And so we can take advantage of some of the features in Git, which was designed to be a distributed system for synchronizing changes with other repositories. Now, what might those live? Well, a couple of common places are GitHub or Azure Repos. There's other online services that can host a Git repository. Git repositories could also be on the same file system, right? And shared across that. But some of the most common we're going to see are like GitHub or Azure Repos or local versions of those type of tools. Now, in team environment, what happens is that everyone would maintain their own local repository, make their changes in branches locally, and then push those changes up to or synchronize them with the online copy. And that online copy, through an agreement among the people in the project, becomes the source of truth. That becomes the primary repository. There's nothing in Git that says, "Hey, this one is the leader and has all of the control," but we do that by convention. Now, Brandon, if we want to add a remote repository, how do we do that?
Yeah, so again, just another CLI command here. So when we're working with a local repository, and as Stephen mentioned, we are destined for GitHub or something like Azure DevOps, all we have to do is do a git remote add, and then we give it a name. So a common term is origin. If you've worked with GitHub before and you know the idea of forks, you may also see the term upstream pretty commonly. But git remote add name, and then the URL to that destination. So git remote add origin, and we can see here it would be my team / our project at github.com.
Awesome. Now, to clone a repository, we can do something similar, right? And yep. Brandon, do you want to walk us through that example?
Yeah. So if let's say that you have just joined a team, open source community or something like that, and you want to bring that to your local machine. So you didn't start the repo, someone else did. It's pretty straightforward. Git clone, and then you put in the URL of where that is stored. So here we can see we're pulling the Azure Bicep repository. So git clone is going to pull that to my local machine, and then we're going to move into that directory with a CD or change directory command, and then we can see the results of that remote.
Yep. Yeah. If you want to see where your remotes are pointing, git remote -v is a great command to be aware of. Now, once we have a remote set up, we can do two things. Well, we can push changes to it, which we talked about, but we can pull changes from it. And the first step in pulling a change is git fetch. And what that's doing is it's pulling the results of that of your remote repo. It's pulling all of the data about that, and it's storing it locally under the namespace of origin in that Git metadata that you have. So once you have that locally, you can merge with our git merge, right? And so we can see the namespacing, right? With so we can see the namespacing of origin main. That's saying from the remote origin, I want the main branch, and that's what's stored locally after we get fetched. Now, and I want to merge that back into my main branch. That series of commands, the git fetch origin main, I want to get the main branch from the origin repository, and then I want to merge it back. That set of commands can be summed up in git pull origin main, which does both of those things, but it does them together. I think it's important to understand that it's doing a fetch and a merge in one command, because if sometimes the merge could go wrong, there could be merge conflicts. And so you might want to do a git fetch and step by step go through and see what's going on. But git pull will combine those two things for you. Now, Brandon, how do we tell these online repositories that we're authorized to do stuff?
That's a great question, and often could be just being totally honest, a source of frustration. So it really just depends. If you go to GitHub and you see an open source project and it's a public repo, many times you can just pull that without any authentication required. It's a public endpoint, you can pull that down. But if you want to contribute and you're added as a contributor, you have to basically tell Git that I am valid to be here. So GitHub and Azure DevOps both have comprehensive processes to do that. It can range from just simple username and password all the way to multi-factor authentication. And to do that, there's a tool that can help you out. It's called the Git Credential Manager. But there are a variety of options. So if you're ever struggling, just ask the maintainer of the repository the best way for you to authenticate.
It's good information. Now, the last concept that we have before we jump into our final demo is to talk about collaboration with others, right? We talked about collaboration and communication. Brandon, how does a shared repository like GitHub or Azure Repos set us up to collaborate?
Yeah, so we've already touched on this quite a bit with everything from the trunk-based development and branching and merging. And then of course we just talked about having remotes and pushing out to those remotes. And what tools like GitHub, Azure Repos, or really any other shared version control system does is that it allows you to not just push your code up to those locations, but you can add teammates. So I mentioned earlier about like being a contributor to an open source project, a team project, or anything like that. Maybe you and a friend want to start, a new app, and they add you to their repository, and it allows you to then integrate and push those changes. So while Git, as Stephen mentioned earlier, does not have a convention to say like this is like the gold copy per se, as a team, you can collaborate and say the repo on GitHub is the de facto source. And now you can work with that and push those changes out there.
And we've talked about pushing changes. One of the things that these shared repository systems add on as a value add on top of Git is the idea of a pull request. And that allows us to have conversations about and do code review and changes the workflow up from me pushing changes into something to me saying, oh, there's the branch I want to pull those changes into my branch. All right, Brandon, you ready to do some creating and merging of branches?
Yes, let's do that.
All right, let's jump back into Visual Studio Code and get to it.
Awesome. So we are back here at the root of my toy website folder. I can see I'm on the main branch. My tooling here says it, as well as down in Visual Studio Code. It shows that I'm on the main branch. So we want to create a new branch because we want to add a feature. So in this case, let's say we want to add a database. So I'm going to do git checkout, add database. So this is the name of my branch. So the -b is saying, I want to create a branch and I want to call it add database. And there I can see switch to a new branch. If I do git status, it's the on branch add database, nothing to commit, working tree clean. So now what we can do is we can go and update a file on this branch. So I'm going to go to the deploy folder here, and I'm going to create a new file under modules. And I'm going to call this Cosmos db.bicep. Go. And I am going to take the content from the learn module. I'm going to go ahead and copy that, and I'm going to paste it here. So here's my Cosmos DB database. I'm going to go ahead and save that.
Yeah, Cosmos is a wonderful thing. And there's actually an online conference going on right now. Oh, today, tomorrow, all about Cosmos DB. So if you, after you're done hanging out with us, that might be a great thing to pop over to Learn TV and check out.
Agreed. All right, so now I'm going to open up the main Bicep file, and I'm going to add a new parameter. So there's my Cosmos DB account name. And then I'm going to add in a reference to my module. So after app service, paste in my Cosmos DB module reference so that I can see that. And then I just saved, and I'm going to close that file. So just like what we did before, we can go over to source control, and I can see the changes that have occurred. So here's my Cosmos file. I don't think my tooling's updated yet because we should see the main Bicep also being, oh, I didn't save. That's why. There we go. And I'm going to refresh. There we go. If ever you see this get stuck, hit the refresh button. So I'm going to open up my main Bicep, and I can see that I have added in that module, and there are the changes to my code.
Great. So how do we get these back? How do we get these changes back to our main branch?
Great question. So I'm going to go ahead and I'm going to go my fancy way, and I'm just going to go ahead and stage all changes. So instead of going to each one, I'm going to add a commit. So added Cosmos DB. I'm committing my changes now. And then I am actually going to switch branches. So as we talked about before, super important. You always want to be in your destination or target branch. So I'm going to do git checkout main, and you'll see that I am now in my main branch. And if I do a refresh here, I could see main down below. And then I am going to merge that add database branch into my working directory or working copy because I'm in the main branch and I want to add those changes in. So git merge add database. And I can see that it updated. I can see the files that got pulled in, 2 files changed, and the insertions that were made. And if I go and open up that file, whoops, if I open up main.bicep, I can see I am now in the main branch, and there are my changes from the other branch.
Awesome. Thanks, Brandon.
Stephen mentioned earlier, I'm going to go ahead and delete that branch.
I love when people clean up after themselves. All right. So if you've been playing along at home, we've had a few poll questions that have shown up in the chat over the course. There are additional knowledge checks and things in the Learn module. So I strongly recommend that you go check that Learn module out, whether it's right after this or sometime in the very near future while this is all fresh in your mind. But there's also one other exercise that we didn't get to, which is taking the module of the project that we were just building and publishing it to GitHub or Azure Repos. There's variants of both in the module. So check that out and give that a shot. But let's just review kind of what we've covered today. We've talked about version control and we've talked about Git specifically as a tool. We've looked at how we can commit Bicep templates to a Git repository. We can see the changes there. We can make changes on a branch and bring those changes back into our main branch with a merge. And we've talked about why we would publish to a GitHub repository or an Azure Repos repository so we can take advantage of some of the collaboration features. And ultimately, really, that's just the start. I mean, there's a ton of other capabilities that GitHub, Azure Repos, and other services offer on top of the Git repository hosting that you can start to explore as you build your comfort with working with Git. Now, to learn more, helps when I'm actually focused on the right thing. To learn more, please do check out that Learn module. There is a summary page at the end of the Learn module with a lot of additional resources, including the full-on learning path about Git in Microsoft Learn. It's called Introduction to Version Control with Git, and it goes deeper, covers the merge conflicts and things like that. And then go take the Learn module, right? We got the QR code there. We've got the AKAMS link. Great way to go get there, check this out, get hands-on with these tools. You don't need any cloud resources necessarily to do this. GitHub repos and Azure repos, you can get started for free. So all of this stuff you can accomplish today.
Yep, highly recommend. Go out, check out the module. You know, working with CLI tooling, as you saw, my fumbling around a little bit. It's good to even get a refresher if you haven't done it in a while. And as we mentioned, there is one more exercise that you can go through that actually goes through the publishing to something like GitHub. So definitely check that out.
And this series is continuing. So come back next week where we're going to dive deeper into that project structure with structure your Bicep code for collaboration. We've got some QR codes to get you to the registration for that and for the Learn module for that. But we'll be back here same time, same bat channel if you're old like me. But it's a great way to come back and continue your growth in using Bicep. Now, Brandon, any final words, any tips, techniques, recommendations for working with Git and Bicep?
Yeah, absolutely. So just like we have with the Bicep modules up to this point, we've talked a lot about the Learn module content and things being out there and available to you. Take advantage of the docs. With Git, take advantage of the open source community around it. There's a lot more to uncover. We literally only scratched the surface today. So take advantage of the community, the documentation that's out there. Stephen mentioned the additional Learn modules for Git. So be sure to go and check those out, and you will be a Git Kung Fu master in no time. So your Git Fu will be strong, and you'll be able to take advantage of that and be working with teams and versioning your code today.
Yeah, and my only suggestion would be start soon. Like start today. Start getting comfortable with it. Your life will only get better. When you're dealing with some merge conflicts, you might question that, but really your life will be better with things with your Bicep code, with your scripts, with your source code in some sort of version control. So get started today. It really is only a handful of commands to get started with a lot of the basic use cases. Git is a rich ecosystem of things to go do. Stay focused on those core things, and you'll be. I think you will enjoy the results. Thank you so much for joining us today. Appreciate it. Appreciate our producer Jason, who's been controlling the stream for us, and Josh for handling all of the chat and questions there. We appreciate you all for spending time with us today.
Yes, thank you both. And thank you all.